Now, paper 1, question 1 shows us a cubic expression, cubic graph, and it is x cubed plus 5x squared plus kx minus 12. And we're told in part A that x plus 1 is a factor. And just in case you missed that, if you look at the diagram very carefully, you'll notice that the cubic graph actually cuts minus 1 on the x-axis, which means that minus 1 is a root. But we also know that if x plus 1 is a factor, then when you set your factors equal to 0 and solve them, they reveal what the roots are. And a root is a value that when you substitute it into a function, gives a corresponding y value of 0. In other words, what we say is when you put minus 1 into the function, you'll get 0 as a result. So that's what we're going to do. We're going to take minus 1 and we're going to put it into the expression x cubed plus 5x squared plus kx minus 12. And we know that when minus 1 goes in there being a root, the value will be 0. It's a value that satisfies the equation. So minus 1 cubed plus 5 times minus 1 squared plus k times minus 1 minus 12 is equal to 0. Minus 1 plus 5 minus k minus 12 is equal to 0. Minus k therefore is equal to 8 and k is equal to minus 8. So that gives me an expression x cubed plus 5x squared minus 8x minus 12. And that's the cubic expression that we were dealing with. Part B says hence or otherwise, and the word hence means following on from what we've just done or using what we've just done in part A. Find the coordinates, not values of x, coordinates of the other 2 points at which f cuts the x-axis. Now, the other 2 points at f cuts the x-axis are roots. The 2 roots also are linked to factors, and those 2 factors when multiplied by one another give a quadratic expression. But if you remember in part A we were told that x plus 1 is a factor. What that means is that if you take x plus 1 and divide it into this cubic expression here, you will get revealed a quadratic expression which obviously houses the 2 factors we're looking for, and if we solve them, we get the 2 roots, i.e. the 2 points at which the f function cuts the x-axis. So let's do a quick division here. X into x cubed goes x squared. Multiply x squared by both of these to re-establish first of all the x cubed and then 1x squared. Take those away, you get 4x squared, bring down the minus 8, start your division again, plus 4x, re-establish as 4x squared when you multiply, plus 4x, you subtract, that gives you minus 12x, bring down the minus 12, and do your division again for the final time, minus 12, and then subtract that, and you get 0 as expected, because we were told x plus 1 is a factor, so therefore there will be no remainder. So where are the other 2 factors? They're in this quadratic expression. So let's take down x squared plus 4x minus 12. And let's open it first of all to factorize it. And then we'll solve it. X by x. Factors of 12 and a difference of 4. 6 and 2. I want a difference of plus 4. So it's plus 6 minus 2. And that means we end up getting x equals minus 6. And x equals 2. Now they're the x values of the coordinates, but the question says find the coordinates. If this quadratic function, or a cubic function, cuts the x-axis at minus 6 and 2, that means the corresponding y values for both are 0, because that's another name for the x-axis. So the coordinates are minus 6, 0, and 2, 0. Okay, and part C then says that they want you to sketch the graphs of y equals f dash of x, which is the first derivative of the function, and y equals f double dash of x, which is the second derivative. The most obvious thing to do is take the function down. F of x is x cubed plus 5x squared minus 8x minus 12. Differentiate it once. That gives me 3x squared plus 10x minus 8, differentiated a second time, and that gives me 6x plus 10. And what they want us to do is sketch this and sketch this. Now, in order to sketch the quadratic equation, what we need to do is find out, first of all, where does it cut the x-axis? So in doing that, we take 3x squared plus 10x minus 8 and find out the 2 values where it cuts the x-axis. So 3x squared is 3x by x. Factors of 8 with a difference of 10 when placed in here will be 4, because that gives me 12, and then 2, so that'll give me 10 by subtraction. I want plus 10 by subtraction, because that's what it's telling me to do. That gives me plus 12 minus 2. You take those factors and solve them. X is equal to 2 over 3, or x is equal to minus 4. And again, because these are the two values where this quadratic function cuts the x-axis, the corresponding value of y will be 0. So that's 2/3 0 and minus 4 0. So these are the 2 points at which the quadratic graph cuts the x-axis. So we go back up to the graph and we plot these 2 points. The last thing we want to do is find out, well, where does this quadratic function actually turn? And if you remember when we were doing differentiation, we said that if you take a quadratic function and differentiate it and solve the result of the derivative of the quadratic expression, it'll reveal the x-coordinate of where the graph turns. So if we take 6x minus 10 and solve that, 6x equals 10, x, when we simplify it, would be 5 over 3. That means at the x value of 5 over 3, that's where the quadratic function is going to turn. And if you want to get a corresponding y value for that, you take this value here back to the quadratic expression, because don't forget we're looking for the turning point of the quadratic expression. So you can take this value of x here right back to the quadratic expression here and substitute it in for x, and that's going to give me 3 times 5 over 3 squared. Oh, sorry, plus 10, that's plus 10, apology, minus 10, minus 5 over 3, minus 8. Okay, so this is going to give me a corresponding y value of minus 16 1/3, or minus 16.33. So therefore the turning point of this quadratic expression is minus 5 over 3, comma 16 1/3. And what you do then is you go up to your graph, you plot that together with the 2 points at where the quadratic graph cuts the x-axis, and you make a sketch down through 2/3 0, or minus 4 0, through minus 5 over 3, 16 1/3, and back up again through 2/3 and 0. What we have to do then is to sketch the second derivative. Now the second derivative is very simple. Second derivative is a line. So therefore, in order to get 2 points in this line to see what the line looks like, we let x equal 0, we let y equal to 0. We already know that if I let y equal to 0, we get a point of minus 5 over 3. So that gives me a point of minus 5 over 3, 0. So that's 1 point on the line. And then the second thing to do would be to let x equal 0. And when you let x equal to 0, that means y is equal to 10. So therefore the second point would be 0, 10. So these 2 points here, when plotted and joined together, will give me a sketch of the second derivative. These 2 points here, when plotted together with the turning point, which is this one here, will give me 3 points through which I can sketch the quadratic function. And once those two are plotted, you've done part C.